was no flying saucer.
This is our test here with the P10. It's a 10 pole, 10 pairs, and 20 coils. It is also, I want this all north with the new type of winding where we have all the pairs clockwise wound. And we have to realize now this motor here, doesn't do the radical changes that the small radio shack does. This one takes its time to climb and time to go down, and it's due that the number of coils is greater. I mean, that little radio shack, it's very small compared to this, not only in coil size but also in number of pairs, and this is what we have to realize here. This is the radio shack right there. So the capacitance of each coil or each pair and the 20 coils in total is retains longer the power, and it gets rid of it slower, which is convenient for us because we got energy rotating, doing all the mechanical action in there for us, which is a motor is for. Normally at low speeds it's almost not noticeable. I have to take it to peak top on the power source. This motor runs around somewhere around 4,800 RPMs max on this power source. It can go higher though, but this power source is 19 volt 3 amps. That's what it's rated for. And let's do this test. The way I have it hooked here is I have the positive here from the power source, the negative here on the two top terminals, and I'm also doing the rear junction. Now these motors actually run better than the south-north coils with the rear junction on. It seems that they stabilize the power better, the way the smoother running, and very much lower amp draw. So let's start turning it, warm it up, and turn on this. I put this little button here to leave it stable there, and it will give us the reading right there. And I hope there's not much vibration. So this is the negative cable that goes into the bulb, and by touching it here, I make it go on. And you can hear that that it's almost not noticeable, the drop of the change on a speed. It's almost, the dropping of speed is not much, and actually sometimes after you disconnect the bulb it goes higher. So it gives you all kind of weird readings. Why? Because you are hooking the system, you know, to a certain amount of load. So you disconnect it and it keeps on retaining the power, just like a capacitor retains its power. After you turn off any supply, it'll stay on for a little bit. The same thing here. So we're gonna go higher, and we're gonna go top speed, which is the max of the power source on both parameters, on amps and volts. Want to make sure that we read everything here. So now it's 49 4900. 49, 24, 28, 30. So we're gonna hook this bulb and watch the amperage, 183. So about it went up like at 1 amp, and it went up 49, 58, 60. So somewhere in there. So it'll remain there. Now I'm gonna hook the power. It dropped down automatically to 4800. You saw it now. 49. It went up, and now it's trying to stabilize in there. 4960. Remember, it was 4980, 90 with the bulb on. So it went maybe 10 RPMs or something. But then again, it fluctuates. It's not a steady curve, and it's not drastic up, steep up or steep down like the Radio Shack did. It's this fluctuation, smoothness. Now, it's 4988, 4990. It keeps coming higher now. So what I do is simple. I put a force here. It comes down, ouch, burn my fingers. 49, 43. I brought it down because I put some force in there. I don't have a wood nearby. 49, 71. 81, 83 is gaining again. Anyways, this is, it dropped down, but it's coming up again. 98, 5,000. See that? So it's going over 5,000, and the power source didn't do that. Now it kept going. It's at 5,008. 16, and it keeps going up. Now, what demonstrates this is that by putting a load on the motor, it demands more. So you hook it up, you get it higher. And this is the way a motor is supposed to be running, like that, with the load, with the mechanical load, and the generating part is also working here. So right now you can see it's fluctuating in 5,010. So I'm gonna unhook this and drop down again to 4,900. All right, now I want to just do a test here for some comments on my YouTube channel, and that they were stating that the power source put the extra power on my previous video on the 5-pole. Put the extra half watt or half amp to be able to light up the bulb and speed up the motor. And I want to demonstrate with the same power source that it doesn't do it. Simple test. It's just a matter of hooking the bulb. It's already hooked up to the power, to the positive, and I'm going to be hooking just here to the power source negative. So we're going to be fitting the bulb and the motor in parallel to the power source, and I'm going to take it to the max first. I'm going to let the motor go all the way to the max, and so here is normally where I've been doing the test. Put it here. Okay, goes over by a few milliamps, but if I put it right here, the motor collapses and the bulb gets brighter. course. So the point is, it's not even worth to measure the reading here. The motor of the RPM reading. I mean, you can hear it how it slows down, and the amps raises sky high. See, these power sources have a compensation, like almost anyone. That, you know, if it goes higher on voltage, on amperage, it automatically reduces the voltage just to keep the same power output. So now I'm gonna do it in parallel, in series, just to take off all the dubs. And on series, the motor will run and the light will the bulb will light up, but the motor will never reach the RPMs that it normally does when we are taking. See, this is sorry. So it's poor lighting, and the RPMs are 2600. And again, you know, the power source is at max. So 2600. So we saw it getting at 5000 RPMs with the other way of connecting. Thanks.